Welcome to Watermark Your Data with Hash Values. Hey, I'm Eric, and quite often in general computing all over the place, we use something known as a hash value. And a hash value is a way to get a watermark, get a fixed size identifier of a larger piece of data. And hash values has a lot of usage all over the world of computing. It's one of the base components in all the encryption that takes place. But we can actually use hash values in Business Central, and there's lots of uses for it. I'm just going to show you a couple of them tonight. Because it's very late here in BC. My Docker just threw up on me and I had to reinstall everything. Lovely. Anyway, it's all good. Everything is running. So let me show you the principle behind a hash value. Here is Windows 10 calculator. You didn't see that one coming, did you? Anyway, so the idea behind a hash value is that you take a arbitrary amount of data and then you calculate a fixed result of that, and you calculate in a way that you cannot go backwards. So let me show a very simple hash. One of the very simple. Let's say I input an arbitrary number here. And then I asked to do a mod 2. So divide by 2 and show me the rest if it's not you're able to not do an integer division with 2. So we got a 1. So 1 is our hash value, because with this method, no matter what I put in, I do mod 2, I get a hash value. And let me end with an even number, mod 2, I get the other hash value. So we can see that this is not a very good hash value. It's impossible to take that 0 or 1 we got out of our hash method and calculate backwards and get the original number. So let's say that and this is quite often how passwords are stored, that you type your password and then you run that through a hash algorithm. In this case we'll use mod 2, and we get the password we're storing is a 0. So we actually don't know your password, but we know the hash value of your password. So the next time you type in your password, we type that. I can't type that thing again, but we will type the same thing. We'll run through the same hash algorithm and see if we get the result we have stored. But if somebody gets hold of the hash value, they don't know what your password is, and it's a very complicated and time-consuming process of trial and error to figure out what is your password. In this case, the problem here with the hash algorithm that I'm using now, mod 2, is that all passwords in the world will end up in 2 different hash values. So you have a 50-50 chance of guessing a password, even though it might not be the same password. It gives the same hash value. So a hash algorithm needs to be able to identify, that's the wrong word, but watermark and be unique based on the uniqueness of the source data, so that even if 1 bit is changing in the source data, the hash should still change. And there's a bunch of cool algorithms that does all this, but we don't care, because we're just the consumer of the functionality. And when it comes to cryptography and all that stuff, there's one very important rule if you don't ignore everything else I tell you in this video, but remember this, that do not roll your own cryptography. Do not create your own hash algorithm. Do not create your own encryption algorithm and so on. They will be broken unless this is all you do. There's a handful of people in the world who are really, really good at this, and they spend 80% of the time trying to break the stuff the other guys did, or girls. And it's a very, very specialized field, and we have seen so many attacks on all these things, and this is software that has been running for decades, and suddenly somebody comes up with a very, very clever way to heartbleed bits out of an encryption key and so on. So don't roll your own, just take what we have. And the great thing about Business Central is that we have stuff. So in System Application App, and I'm on GitHub now. So here's the source code. We have the cryptography management code unit. Let's take a look at this. So this one has a bunch of stuff for encrypting and decrypting, and maybe we should do a video on that at some point. Let me know in the comments below right after you subscribed, if you want to see a video on encryption. But what I'm looking for today is a function. Let's see, there it is, generate hash. So generate hash takes an input string, text, and a hash algorithm, and there's a bunch here. There's an oldie called MD5, SHA1 and SHA256, 384 and 512. So the two first are generally now considered not safe. Not safe is the wrong word, not secure. So you should only use them if you have to, because somebody else requires a hash calculated with that algorithm, or you're verifying something that you got from somewhere else. Otherwise, as minimum, use SHA256 or the other ones. This is the size of the hash. So of course and in bits, so 256 bits, that would be 32 bytes. So the bigger the hash, the longer it takes to calculate, and the more space it takes. Generally, SHA256 is considered secure and is the de facto standard everywhere right now. But by the time you watch this video, it might have changed to the next one. Anyway, so let's try this function out. And I have a Business Central here. I know I have a Visual Studio Code. I have a Business Central somewhere else. Here it is. But I have my Visual Studio Code, and I just created a simple, no, not a simple, I just created a new extension. So let's create a page. How about that? hashtest.al. I think that's a good idea. Page, and we'll get just the first one, hashtest, and the page type is card, and do layout. Let's create two variables here, one called input text and one called hash text. And then we'll just do a very, very simple page here. Wow. Input application error equal all, and hash. Wow. Application error equal all, and we should probably put a caption on this one called input, and a caption on this called hash. semicolon, and then let's add an action here in processing. Action calc, caption equal calculate, application area of course, promoted true, promoted category is process, promoted only is true, and then let's create it. Let's actually do some things. So remember, this was in the cryptography code unit. So let's find that one. Cryptography management. And let's see if we say has equal crypt. Let's be sure that I'm outside of my big head. Generate hash. So we actually have two options here. So generate a hash, that will give us the 32. Let's try it out. Let's actually try it out. So hash is from input, and then we need to supply it with a hash algorithm type, and that's not an enum. That might still be an option. Let's go back to the documentation for a bit. It's an option, so 0, 1, 2. Option fields are indexed from 0 because, you know, Business Central is 1 indexed, so of course options are indexed from 0. So 0, 1, 2. We will pass that in. And I think that's it. So a one-liner to generate a hash. So let's try this out. No, this will break. Well, because I forgot to put in my page number in my launch JSON. Let's just stop this guy and deploy again. Has been successful. There we go. I need to log in. Okay, so let's see. So I put in my name, calculate. So now you can see that we got a string here. And okay, so let's try to say Eric Hogarth. Now I'm gonna change the E in Eric to lowercase, right? So this is 071. Let's actually, we will put this into the clipboard. Let me fire up Notepad. So Eric Hogarth gave this one. So now I changed the only thing I did is change the Eric from a lowercase, uppercase E to lowercase. And you can see that we got something completely new now. So even though we only changed one character, you can see that the entire hash value is completely different. But then you could say, well, Eric, there's a big difference between a uppercase E and a lowercase e. And yeah, there is. So let's try something else. So how about we change one of the A's to a B? So behind the scenes, that's only one bit we're flipping. So from Hogarth to, I don't know how to pronounce that. There's only one bit difference in the source. So we'll calculate this. Let's grab this here. And and you can see again, this is still completely different from the two first. So SHH 256 is awesome, and the likelihood of a collision, meaning that you have two source inputs that will give you the same hash, is very, very little. If there's any computer science on the call here, feel free to calculate the probability of a collision happening on something like this. But in reality, it's very, very low. So unless you're using hash values as a indexing means, where you need to make sure that if there is a collision, you branch out to a new subtree, then it's nothing to worry about. So again, imagine that what I was typing here was my very secret password, doghouse123, and when I register my user somewhere, this is the password I type in. So we get a hash key here. The hash key is what we store. So the next time I come in and I type doghouse one, whoa, I typed it wrong. So we calculate and we get a wrong value. So unless I actually type the right password, I'll not get the right hash value. So that's a great way of handling something like passwords if you need to do that. There are other means to do that in BC, but they're kind of using the same tricks anyway. So that's one uses of hash values. Another one is to imagine that the input here. Let's actually do one thing. We can go back and we can go back. Just I want to see, make this to multi-line true. And then while we're at it, let's actually try the other one. Remember, there were two functions. So we'll change this one to, instead of just generate hash, then generate hash as base 64 string. Let's see how that goes. I'll deploy again. And the first thing I did was I changed the input field to be multi-line, just so we can play around with it. But let me go back and do Eric Hogarth here, calculate. So see, now we got something else. So what we had before was that we got this guy. That's a hexadecimal. So each character represents 4 bits. And now we got a base 64 encoded string. So you can see this is shorter, but it holds the same information because it uses more characters. So the hexadecimal string only uses 0 and A, B, C, D, E, F as characters, where a base 64 uses more uppercase, lowercase letters, and a couple of characters, special characters also. So it's a way to, if you need to give out a something, let's say you're building a license system, and perhaps the license key is a hash value, then it's perhaps nicer to give out the shorter base 64 encoder thing. But what I wanted to show here is that, let's say that we have, a banking thing where let's do something like 1st of 1st 2020, and then we have a account number, and we have an amount, and we have a receiving account number, a file for some e-transfers, and we have multiple lines. Oops, that was not what I want to do. I want to copy this. So we have a CSV file with banking informations, or something like sensitive data that we need to make sure that when it arrives wherever it needs to arrive, it has not been manipulated with. Because let's say that we have a situation where this file gets generated and then it travels, and maybe it travels to somewhere where I have the opportunity to go in and say, aha, I'll just put in my own account number here. So what you can do is you can take this, and in whatever form that is, you calculate the hash, and then that is accompanying as the last line in the file, or the first line, or whatever, however you want to do it. So now we have watermarked this CSV file. I can't say that fast. Anyway, now we have watermarked it with a hash value. So when the receiver is getting this file here, he or her can go in and say, okay, this is the data I get. So I get this, I calculate, and then I get a hash, and I check that the hash I'm getting is the same as the one that the sender sent with the hash. And you can say, okay, but why, Eric, couldn't you, when you went into this guy, just go ahead and also recalculate this one with your new number, and then you have defeated the whole purpose. And sure, but what you it's you know the term when you're salting something, and in this case, what we're actually, it's called that you add a salt to a hash. So let's say that instead of just calculating the hash on this, I add in here a very secret value. This is my salt. So now I have salted the data. So I calculate again, and now I get a different hash, but this thing is a secret. So this thing is only known between me, who creates the hash, and whoever needs to validate it. So now we're still I'm actually just, I'll copy paste. Oh, that's okay, that's gone. So now this is the hash that I'm sending with the file. But if somebody were to go in and manipulate this to put in their own account number and think, I can just recalculate this guy, they would not know the salt, and thereby they will not calculate the correct hash, and the receiver of the file would know that this has been manipulated with. The same thing is done with passwords and so on, that you don't store just a straight hashed, as we just did, the straight hash value. You add something to the password. So when I did the doghouse 123, then before calculating, I would add my secret salt here, and then I would calculate. So if somebody got hold of this, they both had to do the reverse calculation of the hash value, but they also needed to guess my salt, which is a way more complicated procedure. Anyway, I think that's pretty much what I was going to show you guys about this. So it's basically just one function done in the cryptography management code unit. I use it a lot in lots of cases, especially when handling passwords, but also in process processes where I need to actually, I wanted to show you one more thing. Let me actually just do that because this is another place. So let's say we'll just we'll add another one here so it looks nice in case you guys grab this off. Grab this off the off the GitHub. And now it's unhappy with me. That's okay. Let's see if we can. What happened here? What did I break? I copy pasted. Oh, I'm missing action. Customer. Wow, it's getting late here. I can't even type anymore. Calculate customer. So what I want to do here is customer record customer. And I'm just gonna find the first customer at datum. And now I'm gonna use a dirty trick and say format customer. That will actually have create a tab separated text string of the record. If you haven't seen that trick, there's actually a very old, almost 1 year old video where I'm building a search app and using the format of a record to turn records into strings and then be able to search in them. Anyway, so now I'm gonna calculate, and I'm actually just gonna go back to the hexadecimal version here. Just stop this. Come on, there you go. Stop this guy. Deploy again. Now we're cooking. Come on, BC, you can do it. Okay, so if I do this, now I get a hash value here. That's my customer, right? And I calculate it again, I get the same thing. So let's go in and, wow. Let's, come on, BC. Let's go in and change the, let's do this actually same thing. Let's change the A to B in corpoption now. And we'll do calculate, and you see we got a brand new hash here. So what I use this for is to identify if something has changed. A very simple way of looking at complicated data structures in BC. And now I took a record. This could be a JSON object, JSON array, or an XML or something like that. And you can calculate this on anything as long as you can get it as a lump of data in a string. You can calculate. So just by changing one letter again in the customer, I got a whole new hash value here. So lots of opportunities to use this, and it's there and it's available, and you don't have to invent it because somebody else has already done this. And this is based off the cryptography functionality that's in .NET, which has been battle tested a lot. So go for it. That's it for this video. I hope you enjoyed it. If you did, let me know in the comments below. Let me know if there's something else that you want me to do a video on. Subscribe, that would be wonderful. I really appreciate people who are subscribing, because that means that I know that I'm delivering content you want, like. And then until next time, have a wonderful day, and hopefully we'll see each other soon in this interesting world we're in. Bye.